Hello, Walden's Geometry Kids. Nearing the end of the day, I got about 20 minutes here. I'm going to shoot a quick video about introduction to translations on graphs, and it's going to lead to the idea that parabolas, which you're kind of already supposed to be familiar with parabolas, but this is just the graphing portion of parabolas, not how it all ties in and how to solve them and kind of thing. Okay, so I hope all of you are familiar with an equation that says y equals 3. And I hope that you know and already knew going in that this creates a horizontal line. And the reason it creates a horizontal line is every point on here has a y value of 3. So you always go over a certain amount of x up 3, every single point. Now, what I want to show you is that you can actually slide this graph around using translations. If you subtract 2 from the y, it slid the graph up 2 units. Now it's at 0, 5, and all these points have y being 5. If you add 6, it shifts the graph down 6 units. So adding or subtracting something to the y either shifts it up or down. Now look how it actually does the opposite of what you would think. If you subtract 2, it slides it up. If you add 6, it slides it down. So that's what happens when you can add or subtract. Now likewise, if you do the exact same thing with x, so you got this kind of equation. So again, all these points of x being 2. And now you do something to the x. You're going to say, okay, I'm going to let x, I'm going to subtract 1. It shifted the line 1 unit to the right. If you say the exact same thing, but you want to add 7, it shifted this original line. Remember, this is the original line right here. It shifted it 5 units or 7 units to the left to x being negative 5. So when you add or subtract to both sides of the equation, it shifts the line around. Well, it doesn't just work for lines, although it's even going to work for more complicated lines, like this one. The same thing goes. If you take and you subtract 4 from the y, it slides the entire graph up 4 units. If you add 2 to the x, this one out here, it slides the entire graph 2 units to the left. Now I can see it's a little hard to tell that how do you know it go up? Well, it's because of the previous line. We know what's happening here. It's a little bit, it's hard to tell with this particular line sometimes. Now, it becomes more clear if we tilt the line. We can actually change the angle of this line by changing the number out here. So if we go y equals 3x, it's like we grabbed the line and we twisted it. We pushed it up like that. Or if we do y equals 1/2 x, that's like we pushed it down a little bit. So we can actually move the line. So now, if you take that one, you can now move it around. So if you do y minus 3 equals 1/2 of x, it shifted the whole line up 3 units. If you do y equals 1/2, now it's important you put parentheses here, x plus 6, it slid the entire line left 6 units. All right, now you can do both simultaneously. You can do y minus 3 equals 1/2 of x plus 4. And now you've taken the graph and you've slid it up 3 units from where it originally, and then left 4 units. So left 4 units, that's what we did here, and then 1, 2, 3, up 3 units, right at 4, -3. So you're sliding the graph around, you're translating, we're mixing what you're learning in geometry with translations with what we're doing, what you were doing in Algebra 1 with lines. Now, the cool thing is it's not just limited to shapes like lines. You can have something that's really unusual, like this. This shape is called a hyperbola. It's a really unusual bendy shape, right? It's got all these weird, it's kind of curvy and weird. It goes up and goes down. Well, the same thing happens. If I do y minus 2 equals 1 divided by x, I've shifted the entire graph up 2 units. If I take y, now again, where you put the minus is important, it has to be down here on the bottom. I shifted the entire graph left 1 unit. So it doesn't matter what type of graph we're doing this to on the coordinate plane. You can make these same adjustments in all different types of graphs, and you end up with the same type of results. So now we're going to talk about the quadratic equation. Quadratic equations. Quadratic equations are equations with a squared term in them. This is the base quadratic equation, y equals x squared. Its vertex, that low point called the vertex, is at 0, 0. Now, the same thing goes. I can shift this all over the place. If I subtract 2, now we should anticipate by subtracting 2, it's going to rise 2 units. And then I'm going to add 5. Now, if the y subtracting units means go up. The x to add 5 units means we're going to go left 5 units. So if I hit squared, my original vertex was at 0, 0. My new vertex is at negative 5, 2, because this moved it left 5 units. This moved it up 2 units. So we can also do the stretchy bendy thing where, in the line we were doing this. Well, if I make this y equals 3x squared, it's as though I grabbed it by the thing and started pulling it up. It's called a vertical stretch. If I did y equals 1/4 x squared, it's like you took it and you pressed down on that green one and it kind of opened up and it made the big U much larger. Notice the origin, the vertex didn't change. They're all 0, 0. You didn't slide it anywhere. You just changed how it grows. It either grows faster or slower. Now, one other thing you can do is you can multiply by a negative. What that does is it flips it over. Again, notice they all share the same vertex. You haven't moved that vertex at all. You're simply stretching, pushing, flipping, you're turning, you're doing things to it. All right, so that's the idea of the base equation. Now, again, you can go back and you can completely type this in. Okay, so y plus 2 equals negative 1/2 of x minus 6. Now, we should know, before I put the squares on there, my vertex is going to be 6 units to the right and 2 units down. It's got a negative here, so it's going to open down, and it's a 1/2, so it's going to be a little wider. There it is. My vertex originally was 0, 0. It's now 6, negative 2. It's flipped over, and it is a little wider because I did the 1/2. Totally